Okay, good morning. Just wait until your classmate has come, and we will start the lesson very soon. You know where we are now, okay? We are going to proceed to the topic energetics, okay? Which is textbook 3C. So we have got a few more three more topics to go, including rate, equilibrium, as well as finally it is the periodic pattern. Okay, so just see our progress and that may be you may make use of some of the lesson during daytime to proceed to the exercise of questions unavoidably. But don't worry because we are still ahead the schedule. So and for the better preparation of the coming final exam, we need to have a recap of the experiments as well as some concepts. Well, before you proceed to paper one. So remember, paper one comprises the largest percentage of those paper in your chemistry. You know that 60% is paper one, you know it. And then we have got about 20% it is for paper two, and finally the 20% will be for SBA. So and we need to have a good preparation of all those. So, why can I? Yeah, somebody is still outside. Yeah, I just added to all of you. So do you get my point? I would like to repeat those important sentences. The first one is on the chemistry part is 60% is paper one, and 20% is on paper two, and the remaining part is 20% is for SBA. It is for Chem, DSE. Okay, this is what I would like to remind all of you. And shall we start now? Are you ready? Any questions before we proceed? Now, I may spend some time on you on the introduction of SBA by using another video clip. Okay, such that all people, the students from Chem 1 and Chem 2 can take a look on that together. Okay, so today we focus on energetics. And after the video has been launched, I would urge you guys to opt the options of how you need to come back on Monday and Tuesday. Okay, you know that Wednesday it is our first lesson of your of the class resumption, but we need to let you guys to come back 1 or 2 days earlier. Now, before that, anyone who cannot manage to come for the first 2 days, you have to let me know. Okay? No. So for the time, I will give you in due course. Okay, so you can choose. Because of social distancing, I need to separate your classmates right into several slots. So, but I will allow you to opt freely, and you have to do it at a first come first serve basis. Because of the limited places for doing the experiment together. So, shall we take a look on the topic 8? Okay, chemical reactions and energy. So the chemical reactions, you're going to talk about energy changes, but in particular, in chemistry, we talk about heat. For work done, you know that that exists. But for some reactions involving gas production or consumption, don't worry. But most of the time, while you talk about chemical changes, it will usually involve the taking in of heat. We call it endothermic reaction, or the release of heat, we call the exothermic reaction. So we have got that two concepts that has been introduced to you in this topic. So you are going to talk about some basic concepts about energetics. You need to know that enthalpy terms. So this is the key part I would like you guys to know about the enthalpy terms. Well, we have quite a lot of enthalpy terms with a definition. You have to memorize that. And you are going to do some practical work. You see that practical work of a simple calorimetric method and quantitative treatment of a Hex law can help students to better understand the concept of energetics. That's why this part I would also introduce as one of the SPA. Okay, so together with titration experiments in another SPA, if at least you need to have that two SPA, which help you and have an easier life of those. For organic chemistry, this experiment I would like to I will also try to have a uh, on a trial on the experiment, but I don't know whether or not we still have time, because time is always running short. I don't know. So the use of equipment just like bomb calorimeter that you know in past paper, in a very long time ago, is not expected. So don't worry. But the concept behind it will you may know it very easily. It is because of um, I want to attain the assumption, right, that the heat released due to the reaction is all be absorbed by water. Okay, so this is what you know about bomb calorimeter. Now, so shall we take a look on those three parts, a very short part for energetics, but for the calculations part, it may take you some time. Now, the energy changes in chemical reactions, all those can be set as by the chemical by the science principle, conservation of energy. Okay, so which tells you if you have got a different energy level of the reactants and products, okay, what will you tell is about there will be energy taken in or energy given out. And what is the form of energy? It is in form of heat. Okay, so this is what you may know that. Because of that, for scientists, we usually measure this term, a change of heat, as a enthalpy change. Enthalpy change, which is measured by the heat change at constant pressure. So you are going to explain diagrammatically the nature of exothermic endothermic reactions in enthalpy change. Diagrammatically, which means you are going to have something like this, okay? We tell the reactant to product, it is exothermic, while we have got another scenario. We have got the reactants having a lower enthalpy level than the product, it is a type of exothermic reaction, right? Both data we have got, you can calculate it as enthalpy change, but one of them carry positive data, one of them is negative. And you may also need, can you see that explain, right? You may also see that you are going to relate it to the breaking or formation of chemical bonds, okay? You know that break bond requires energy and form bond release energy. Okay, so this is what I would like you guys to get to know this. Is that clear? And what's next is about standard enthalpy change of the reaction. Of course, you need to identify to define what is mean by standard condition. So what is the standard condition? As I said before, right? 298 Kelvin, 180 M. It is what is our standard conditions, with particular reference to neutralization, formation, and combustion, right? All those three terms, the definitions that you need to know. So remember, for most of the time, we talk about the term per mole of something. So you need to memorize what is mean by per mole of what. And second is about the process. Okay, what happens during neutralization? Now you may find it can be it will occur in reality, right? How combustion, similar is combustion, it will also occur in reality. But you have got assumption, right? The assumption is the combustion is complete. But one equation is very strange to all of you, which is that, what is that? Which is the formation, right? This one is very, very strange. Why? Because do you know why? Because you would find it rare to have a real reactions in our daily life. But for the use of this term, it will give you much convenience for you to do some estimation of delta H. And so such that we need to introduce to you. And carry out the experimental determination of enthalpy changes using simple calorimetric method. So you have got two cases. One is calculate delta H of combustion. The other one is delta H of neutralization. So you need to get to know the label setup. And finally is to do the calculations, right? The calculations. Remember per mole of what you need to identify well. Last but not least, you need to get to know about Heck's law. So what is mean by Heck's law? The definition you need to know. And second, you are going to construct some enthalpy change cycles. Okay, so the word simple is very interesting to get to know what's meant by simple. Okay, I don't know any idea about the word simple, but I expect you guys who can manage to not only draw the enthalpy cycle correctly, but also do the calculations, right? So besides using cycle method, you may use algebraic method, right? You just rearrange the terms with a correct multiple, with a correct direction. You know that direction should go with the sign of the delta terms, okay? And then make a sum up. Do you still remember which is in which we talk about calculations? Any questions so far? For those all of the terms, anyone who think that you can manage, okay, could you please put a tick? You barely remember, okay? Some of you really forget what is that course, please. I just want to get to know your understanding so far. Who made a cross? Take a look. You forgot, right? So you better refer to the YouTube. Okay. 粵斌、劉允正、徐家榮。老師話 you forgot, right? You have disappeared for quite a long time, right? Together with 徐家榮. When will I see you again? Is it next Monday? And 文希、劉允正. Oh, we have got another, right? We have got two versions, right? So, this is what I would like to talk to you about this part. Now, for the remaining time, I would like to show you the exosummation type questions, similar as before. Okay, just want to have a warm up and we need to get to know what is that. Now today, wow, we have got 35 exosummation type questions. Can you see that? We have got 35. So we have got quite a large amount of people who are going to join this. Okay, at least you need to do two times, okay? You need to answer them twice. Together with Heck's law, we have got 5, altogether 40. So I do think you can manage them all. Can you manage them all in 40 minutes? Let's start. For number 1, 趙家明. For the same volume of water, the heat capacity of water is 60 degrees is higher than that of a water at 25 degrees. Wow, what is that? What is mean by heat capacity? Is something related to physics, right? Isn't it? So the higher the temperature of the substance, the greater is the heat. Is the you cannot see it. You better let me know now. This one is it better? Now, question 1. For the same volume of water, the heat capacity of water at 60 degrees is higher. Is question 1. is larger than that of the water at 25 degrees. The higher the temperature of the substance, the greater is the heat capacity is. So what is that? What is mean by heat capacity, right? If you don't know what's that, you cannot answer, right? Heat capacity is different from the term specific capacity. But I do admit that in chemistry, we would not go into a detail to make a difference between the two, right? You know it. So first of all, you know the unit of heat capacity. 趙家明, you know what is the unit of heat capacity? No response. Joule per. Anyone study physics? You didn't study physics? Hey, 趙家明, where are you? 趙家明. Joule per mole, first time. Joule per mole. No, it's not Joule per mole. Any other people who can tell the heat capacity in physics, right? You may know it is a joule. Yes, joule per degree Celsius or joule per Kelvin. Okay, so the terms gram has been already embedded inside the data. So the heat capacity of certain substances is together with the mass, okay, with the corresponding mass. So they will have different amount of heat capacity. Okay, can you get my point? So it is nothing related to what? It's nothing related to the temperature of those water. Can you get my point? So what is the answer? It's related to the material. It is related to the it's also related to the how heavy it is, right? To the mass of it. So it is cross and cross is D. Question 2, Wu Galam. During the decomposition of limestone, the energy required to break the existing bond is less than the energy released from bonding new bonds. So what is the hidden message, right? You will tell this type of a reaction is endo or exo. Now this endothermic reaction, but you take a look on the term. Now enthalpy level, we have got reactant, we have got product. Now, so you may see the word energy required to break the existing bond. So what is that? So you may imagine where we have got the breaking bond like this, right? And then it's less than the energy released from the forming new bonds. So we have got what? We have got energy released by formation of bonds. So we have got that this. Now, because I tell it is an endothermic reaction, so can you tell the relative amount of those two? Of course, from magnitude, right? The bond energy required for the bond breaking is not less, is larger than. Can you get my point? So, and such that we can make the enthalpy level, enthalpy change greater than 0. So can you see the word? Okay. This time the word less, this part is wrong. Change it to larger than. Is that clear? Okay, good. Mình thấy all combustion reaction are exothermic. In a combustion reaction, the energy required to break the existing bond is less than the energy released from forming bonds. Yes, cause and effect logic, right? So if you know something about this, you apply this concept, okay? So this time it's less than it's correct, okay? Which tells us exothermic reaction is A. Good. Breaking of the chemical bonds is the endothermic process. Energy is required for breaking the chemical bonds. Yes, very good. It's A. It's A. Okay. Why? Why you need to break the bond, you need energy. Why? Because bond is just a type of what? You know, it is a type of attraction force. So you are well, if you want to talk about break the bond, which means you are going to put the two particles apart to infinity. So this is what the basics of the physics. Okay, we call that a type of Coulombic attraction. Have you ever heard of this term, Columbic Attraction? Okay, is it something about physics? Who said no? Because you didn't study physics. For those who are physics students, you know what is that? Okay. I cannot comprehend what is meant by nowhere yes here. So question 5. 陳進希, the electrolysis of water give hydrogen and oxygen as an exothermic process. The enthalpy change of formation of water from hydrogen and oxygen is a negative quantity. 陳進希.陳進希. Yeah, your choice please for question 5. It's the first one is not correct. So the term is not endothermic, is endo instead of exo. How about second? Negative quantity. And you may find the word formation. Enthalpy change of formation of water from hydrogen and oxygen is a negative quantity. So what is that? What is that? If you talk about enthalpy change of formation, which means hydrogen, oxygen to form what? To form water. So you are going to refer to this equation. So negative quantity of enthalpy change, which means delta H is negative. So exothermic, which means gives out heat. Is it correct for this reaction? Right, a very authentic pop sum test, right? So this is exothermic. The answer is cross and tick C. Don't worry, you need to read the questions very, very carefully. And who will be the next one? 朱俊輝. Question 6. Freezing of water is an endothermic process. The enthalpy of the liquid water is less than that of the ice. Number 6 is D, correct. Okay, both are crosses. So why is it? A freezing of water is an endothermic process. The enthalpy level of the liquid water is less than the ice. So you are going to relate to these. Ice is here, water is here, and steam is here. So the freezing of water refer to what? Yes, that's right. Refer to this process, freezing of water. So downward arrow, which means delta H equal, which is and negative data is exothermic. Can you get the point? Now, I do hope by could you please put a star here, right? Could you please refer to this part? I'll get to know what I'm now going to talk about. Okay, we will help. 7. The decomposition of ammonia to give N2 and H2 is an endothermic process. For this question, 你真嘅 energy release from forming 1 N triple bond and 3 HH bond is less than energy required in breaking 6 NH bond. Decomposition of ammonia. 做咩 ？Yes。我哋嗰邊個雪櫃咧，我哋暫存一陣先。OK， 好啊。 Lê Dân Kiệt, where are you? Could you please tell me your thoughts? Now, first of all, do you know the equation, the decomposition of ammonia? So what is that equation? You don't know anything about that? So what is that equation? Ammonia to form N2 and H2. So have you ever seen that similar equation before? Have you ever seen the similar questions before, equation before? I give you a clue. That equation is very similar to one industrial process. 3, I locate the source for you, is in chemical equilibrium, is in periodic pattern. Haha, process. Lại Văn Trình, harbor. Do you know what it means by harbor? Now that harbor is different from that harbor, okay? So we talk about harbor, okay? Harbor is a surname of a German scientist. Haber, not OR. If you say that Habour, right? You know what's that? Victoria Harbor, right? We've got the sea, right? The sea area. It's different. Harbor is a surname of a German scientist who invented that, who discovered that you can produce ammonia from nitrogen. It is from atmosphere and hydrogen. Okay, and ammonia is a very good raw materials of making chemical fertilizers. Okay, at that part, you if you write down as a forward reaction, it's a forward reaction. It's just a reverse, right? It is. Can you still remember? Okay, so is it endothermic? If you write down the reverse reaction, exo for Haber process. So what is that? 朱俊輝 where are you? 李振傑 sorry 李振傑 7 李振傑 yes, both they are correct. Haber. So the original questions Haber process is delta H is -0, okay? It's negative. So this is what the answer is A. Question 8. Cyrus the standard enthalpy changes of a reaction are measured at 0 degrees. The enthalpy change of a reaction is only affected by the temperature. It's D. Both are wrong. Both are wrong. The first one, which part is wrong? It's not this one. It's not 0 degrees. It's 25 degrees Celsius. So in Kelvin temperature, what is that? What is it in Kelvin temperature? Yes, 298 Kelvin. So remember, it's our scientific notation about the temperature. How about the second statement? So enthalpy change of a reaction is only affected by the temperature. No, it's not by temperature. It's by mole. Yes, the mole of the substances to be measured, and also what? The reaction nature. So what is the chemical reaction itself? But remember, if you want to talk about enthalpy change, it's measured in per mole. Okay, this factor has been embedded inside. Can you get my point? So it really depends on the units you are going to talk about. If your unit for this enthalpy change it is kilojoule per mole, right? Which means I have included the factor of per mole inside that. So it is not related to thermal, but the reaction nature, it is the only thing which will tell you the magnitude and as well as a sign of enthalpy change. Is that clear? Do you manage? Can you get my point, Cyrus? How about another Cyrus? Question 9. Under the standard conditions, diamond is more stable than graphite. Wow, very authentic questions. The enthalpy of diamond is lower than that of graphite. Cyrus Yu. Cyrus Yu. Now, in order to get to know what are those two, tell me. Now, if you want to tell the most stable state of the carbon, is it diamond or graphite? Now, it's quite difficult to remember, but once I tell you one example and you can tell. Now, for example, if you are going to ask me, ask about the delta H of formation of calcium carbonate, so what will you write on the left-hand side? If you are asked to draw, to come up with this term, do you know? What are you going to write? It's calcium, right? Oxygen, 3/2O2, right? And how about carbon? So yes, I write down C graphite. So why is it C graphite, not C diamond? Do you know? Yes, it is most stable. Graphite is the most stable form of carbon as an element. So it is. So I write down as C graphite. So take a look on that statement. Can you judge now? Cyrus, for question 9, what do you think? A, B, C, or D? Again, now, if you write down this way, now can you manage to write down the diagram which helps you to get to know what are those two? Which one has a lower enthalpy level, diamond or graphite? Now you say that graphite is more stable, right? So the first statement is not correct, okay? It's wrong. It's graphite. And diamond on here. So how about question, the enthalpy of diamond is lower than that of graphite. Take a look on here, please. Now, so how would you relate to the enthalpy, not enthalpy change? You see the enthalpy, which means enthalpy level, which we call about that, okay? That relative position, but not the change, okay? You see enthalpy of diamond is lower than that of a graphite. So what does it mean by that? The one which has the lower enthalpy level, you will relate it as it is more stable. Okay, could you please highlight this part by yourself? Okay, lower enthalpy level, more stable. Graphite, graphite is more stable. It's D. Okay, can you get the point? Any questions? Shall I pass the time to Pong Gao? Sub. Question 10. Question 10. The enthalpy change of formation of a substance is the enthalpy change when one mole of a substance is formed from its elements in their gaseous state. The enthalpy change of formation of any element in the gaseous state is 0. It's D. How wrong is the other two statements? The first one. It's not from the gaseous state, which is what? Yes, at its most stable state. So most stable state is not necessary to form it as gas. So the second statement, formation of element in its gaseous state is 0. No, it's not. Because at the most stable state, it is not necessary to be gas. It can be solid, it can be liquid. Okay? So if you say that in different state, of course, the envelope change of formation is not 0. Can you manage? Can you get my point? Because it involves change in state. If you have got a change in state, of course, it will have a change in envelope level. So the answer is D, correct. 梁善偉 11. The standard enthalpy change of a combustible substance is the enthalpy change when 1 mole of a substance, is completely burning 1 mole of oxygen under standard conditions. The unit for this term is kilojoule per mole. Yes. Yes, it is 1 mole of the substance is completely burned in oxygen. Okay, so the oxygen here, hidden message is in excess. So remember, this one should be in limiting. Then this one is in excess. What is the purpose? Why you need to make limiting for the 1 mole of fuel to be burned and leave the oxygen in excess? You have got 2 reasons. Do you know what are the 2 reasons? Why? Reason 1, you are going to make sure there is a complete combustion. Okay? Question 2, you are going to make an accurate measurement that ensures that we have got 1 mole of the fuel has been burned. Has been burned. Okay? For the calculations. So what happens to the 11 is cross and take C. 12. After 梁兆偉笑話 12. The standard enthalpy change of a combustion of carbon equals to the standard enthalpy change of formation of carbon dioxide. The 2 reactions both involve carbon. Is C. Now, the second statement is correct, but the first statement, you are going to refer these 2 statements. The standard enthalpy change of a combustion of carbon. So can you write down the equation involved? So 1 mole of what? 1 mole of carbon. React with oxygen to 1 mole of CO2. So you write down it as delta H of combustion of carbon, which is in terms of graphite, of course you know. Okay, it is graphite. How about second statement? The standard enthalpy change of formation of carbon dioxide. So from this angle, you are going to relate what? Relate to carbon dioxide as a main role. So carbon dioxide we have got main is for 1 mole. So how can we produce 1 mole of CO2? I need 1 mole of graphite and 1 mole of O2. So take a look on those 2 equations. They are the same. So that 2 enthalpy terms, they are also the same. Okay? So for question 12, it is both statements are correct. But that 2, they are not related to each other. So the answer is B. So go back to the definition of standard enthalpy change of combustion and standard enthalpy change of formation in order to answer the questions. You got it, 老師話? Okay, 老師話 you got it. How about 徐家榮? 13. The standard enthalpy change of neutralization between HCl and KOH is nearly the same as that between HNO3 and NaOH. The 2 reactions involve both a strong monobasic acid and a strong alkaline. 徐家榮. is you write down as A, not question mark. The answer is A, not question mark. Okay, it's a cause and effect logic. Okay, so you may find there is a strong acid, strong alkaline combination, and as well as the acid is monobasic. Okay, why? Why are they nearly the same? Why? Do you know? So in order to answer that questions, you need to refer to the ionic equations. Both equations, they will give the same ionic equations. Somebody will say that one more water. Yes, you just tell me the fact, but you did not tell me the reason. The reason is to refer to this, right? Both carries the same ionic equation. Okay, with both acid and alkaline completely ionize or dissociate in water. So no extra energy is needed for the breaking of the bond involved in ionization, right? So as written as the full ionic equation like this, if you write down all those stages per mole, of course, the data of delta H of neutralization is the same. If we say the standard, right? Standard condition, which is minus 57.3 kilojoule per mole. Is that clear? 陳偉豪 14. 14 is D. Both are wrong. How wrong are they? Yes, it's nothing related to how many moles of acid. No alkaline. Okay? You are going to tell me 1 mole of water to be formed. Okay? The standard effort is, first of all, is not correct. Second statement is of any acid is this. Yeah? It's minus this part. No. It depends on the strength of acid. Okay? You will say that strong acid, more negative, nearly equal to this. Okay? But you talk about weak acid, is less negative. So we have got a negative sign, but that data is smaller. So we got a less negative. For example, minus 55 point something. We call it less negative. You understand? So the answer is both are crosses. D. 15. 如入泵. In an endothermic reaction, heat is released to the environment, social surroundings. Okay, tell me how wrong it is, the first statement. Heat is released, you talk about what, right? It's referring to exothermic, right? For endothermic, heat is absorbed from. So this is the technical term, absorbed from. Okay, circle that. Okay, it's opposite. It's C. 袁天佑 16. The enthalpy change of exothermic reaction is a positive quantity. 16. Yes. Okay. Both they are wrong. How wrong are they? Exo, it is negative, right? Exo, heat is transferred from the surroundings to the system is quite the opposite, right? To and from is different. You're going to release heat to the surroundings. Okay, so it's D. 17. 雍正南 is C. Yep, correct. And how about the first statement? How wrong? The total enthalpy of the reactants is greater than that of the product. It is not correct. The enthalpy level product is higher. Okay, is that it's not greater than. Okay, this one is higher. Higher enthalpy level. How about next question? 趙家明 18. Evaporation of ethanol is an exothermic process. Evaporation, exo. At delta H value of a process is a negative value. 趙家明. It's endo, yes, it's endo. It absorbs energy, so the data is not negative, it is positive. So what is the answer? Question 18 is D, okay? It's D, thank you. How about 19? 胡嘉倫, the conversion of a liquid water to steam is exothermic process. The enthalpy of a liquid water is greater than that of the steam. Yes, you use the logic, right? This part, remember how you tackle that problem, right? You may find that you will appear very often, right? So remember, you are going to draw it as ice, water, steam, and think of this process and you may help. Okay, 20. 20. 問起 the combustion of methane is an exothermic and endothermic process. In the combustion of methane, the total enthalpy of the product is less than that of the reactant. 20. 問起 what do you think? You may think it's the first statement. The combustion is exo, right? The combustion is exo. It's wrong. How about second statement? Combustion process, the enthalpy product is less than that. Now for this part, how will you present it as an exothermic reaction? You use this diagram, right? So which enthalpy level is higher? You know it is the delta H is carries in the minus sign, right? Reaction is here, product is here. Okay, can you get my point? With the delta H value smaller than 0. So comment on the second statement. Again, 問起 the total enthalpy level of product is less than that of reactant. The product is less than. Is it correct? Okay, cross and take C. 唔起 you got it? Hi, 問起 where are you? Why? Oh, all right. So anyone who can further explain? For question 20, you don't understand the second statement, right? Now, so what is mean by the total enthalpy? Enthalpy here is different from enthalpy change. We talk about heat level, okay? Level of heat. So we call it enthalpy. Or somebody, you will see the term enthalpy level. So what is meant by enthalpy level? Enthalpy level refers to just this line. This one of the line, right? But if you want to talk about enthalpy change, it's another concept. If you talk about enthalpy change, it is this part. You make a difference between the two. So in this case, you talk about enthalpy level. Okay. The one we place higher in the enthalpy level diagram, of course, it has a higher enthalpy level. The one lower, I don't want to say something meaningless. High 21. Okay, the one is high, the one lower is lower. Okay, 嚟穩正 21. 嚟穩正 21. The first statement is, yet what is done is correct. This one is exothermic, correct. The B is not related. Why is it what is done? Why is that what is done? by the system on the surroundings. Why is that a work done? So what does it mean by work done? In chemistry, we relate to, yes, we relate to a gas production, which will make to have an expansion of a system. Okay, because you have got some gas form. You know, it is hydrogen, right? So it will make that it will contribute to the work done. Understand? So, but that two statement is not related to each other. 22 or 陳俊熙. Chen Junhei, Chen Weihao, Zhu Junfei, you just follow, right? 22, 23, 24. 22. Chen Junhei. Chen Junhei. 22 is D. Both are wrong. Both are wrong. Now, how wrong are they? The first statement, hydrogen iodine react to give Hi a constant pressure. What is done by the system to the on the surroundings? It's wrong. How wrong are they? It's just exam skills. You know that the second statement is wrong. So the only choice for making the second statement surely wrong is D. So you just did as D. But yes, that is what I would like to ask you. Why would you think that the first statement is also wrong? It's not by exam skills, please. It's not 1 mole, it's 2 mole. So once you know the second statement, you should know the first one. Why do I say so? It's because if you want to calculate the overall change in number of moles of gas particles, what is the change? I repeat, the total number of moles of gas particles in the system. I'll take a look at the left-hand side, altogether 2 mole. Right-hand side, 2 mole. So my question is, what is the overall change in the number of moles of gas particles in the system? Let me put it this way. If I measure it as the constant pressure, will experience a expansion or the contraction of the volume of the system. Chen Junhei, do you know the answer now? Okay, the system will not be expand, right? Or shrink, right? So, can you get my point? Contract. Why? Why you say it's contract? Can you see the statement is gas, gas, and gas? Iodine is a gas, right? In this situation. So we have got 1 mole for hydrogen, 1 mole of iodine to form 2 mole of Hi. So all those reactions is carried out in a what you call it as a system, is a container inside. So what is the change? What's the change in the number of moles of the gas? Can you get my point? Yes, do. Is it contraction of the system or the expansion of the system? Yes, no change. It's not no. Is we have got no change. So The answer is yeah, it's D. So some technical issues I need to return to do. Can you see that now? Oh, we've got 22. Oh, we still have got quite a long question. Some more question to go. How about Ren Xunwei? Who is the next guy after Chen Zhenhei? Chen Wenhou, first of all. 23A, cause and effect. Okay, no need to explain. 24. Next, who is the next guy? Zhu Zhenfei. 24, also A, cause and effect, right? You can explain. 25, 雷震傑，雷震傑。Formation of graphite and diamond are both 0. Of course, it's not, right? Which one is 0, right? Graphite, this one is 0. Diamond is not, right? Diamond is more, it's not, it's less stable. So the formation of diamond, we give you a positive data, right? Delta H of formation is greater than 0. Arrow drops is correct. I see. Thank you. How about next guy? Is it Cyrus and actually 26. Cyrus actually. Cyrus and actually. Yeah. 26. What do you write? Yes, cross and tick. How long is the first statement? Enthalpy change of formation of O2 and O3, they are both 0. Again, which one is correct? Is for O2, for O3, which one is more stable? Yes, this one is 0, but this one is not. 27. It's 27. Cyrus Yu, delta H value of a conversion of diamond to graphite has a positive sign. The enthalpy of diamond is greater than that of graphite. From graphite to diamond, positive. So we relate that enthalpy level diagram again. Which one, which is which? Yes, second statement is correct about first statement. Graphite is here. Diamond is here. The conversion of diamond to graphite. The delta here, it is greater than 0 or smaller than 0. Cyrus. How you calculate delta H? Final minus initial, okay? So, how about the first statement? It is downward arrow smaller than 0, okay? So it's not positive, it's negative. Cross and take C. 房間號 28. Standard enthalpy change of formation of H2O is 0. It's not, it's 0. Both are wrong. First statement, it's not 0. Formation of H2O, how will you get to know? It's hydrogen, oxygen to form H2O, okay? To form H2O, and then with half mole of O2. So it is a type of exothermic reaction. So you know that the first statement is not correct. How about the second statement? Of the formation of compound is 0. Oh, okay, no, of course not. It's D. Of element is 0. For compound, no, it carries the data. 29. Let's see why. B. Both statements they are correct. The carbon dioxide is more stable than its constant element. The formation of carbon dioxide is often understood exothermic, more stable, exothermic. Is A, is that? Or somebody would just want to argue is B. Because of the fact that the reaction is exothermic, the chemical is more stable. Or because the gas form is more stable, the product is more stable than the reactant, the enthalpy change, the reaction is exothermic or not related. It seems A is a better choice, isn't it, right? Agree? Once you say the second statement, you will explain the first statement. It seems more makes sense, right? 30. 老師話 the standard enthalpy change of combustion of hydrogen is equals to the standard enthalpy change of formation of steam. Wow, a very authentic questions. Both enthalpy terms refer to the change to form steam. Agree? How about the others? You say that is A. Do you write down steam? Hongao, what do you think? Steam. Formation of steam. For these questions, you are going to refer to this. To form steam is gas, right? How about for combustion of hydrogen? How will you write down the equation? It is hydrogen, oxygen to form H2O. How about the physical state here? It's L, it's liquid. So are they the same? Are they the same? Equals. Are they the same? But this one is wrong. Second statement, also wrong. It's D. It's not A. So remember, it's not correct. A very tricky question. 31. You get it? Or 除九榮 31. Last 10 questions. Go, go, go. Okay? 除九榮. The standard enthalpy change of the combustion of methanol is greater than that of ethanol. The standard enthalpy change of combustion of alcohol decreases as the number of the carbon atoms in one molecule increases.徐家榮 I think is C. The first statement is not correct. The second statement is correct. Now take a look on that two statement. Now I would like to circle this question to you and put a 3 exclamation mark here. Do you know why? Now it's very, very confusing, I must tell, because if you want to talk about combustion, standard enthalpy change of combustion, you talk about comparison value, we seldom use the term greater than or the less than. And also with the term decrease, right? It's rather confusing. Do you know why? The delta H of combustion is an exothermic reaction, which means the delta H value is a negative data. Okay? We've got the negative data. We've got the negative value. So if you want to compare that two difference in the data, it is quite confusing to use greater than and decreases, right? Instead, what terms do we use? What terms do we use? "31, I would not use this. Please cancel it." What terms do we use? If I want to change it correctly, what can we use? Then you compare the two negative data. What terms do we need to use? You use the term more negative or less negative. Okay, could you please mark it now? More negative, less negative. So for this term, change it. So what is the fact? Ethanol, combustive data of ethanol, from methanol, from magnitude, which one is greater? But ethanol magnitude is greater. Okay, so but if you want to express it that more or less negative, it is less negative for methanol, more negative than ethanol. Okay, becomes more negative. Can you get the point? For those who you can manage to answer to get the logic of my thoughts, could you please clap your hands? You get what I mean? Just one. So now, first of all, take a look on that Julian right now. If you want to talk about combustion of alcohol, you're going to measure it as one mole fuel, right? One mole fuel. If you burn 1 mole of ethanol, or if you burn 1 mole of methanol, which one will produce more heat? Do you know? It's ethanol. Okay, it's ethanol, 2 carbon. Okay, which complies with the fact with your common consensus that the bigger the molecule to be burned completely, the more energy to be released. Okay, can you get my point? So I would mark it as more negative for that. This is something about organic chemistry, you know it, right? So I would like to put it like this way. You get a point? Now, most of you can get it. Good. How about the next one? The next guy, the standard enthalpy change of neutralization between HCl and NaOH is the same between ethanol and NaOH. It's wrong, okay? It's not the same. How you make it correct? It's not the same. Besides, you write it not the same. Can you tell me more negative or less negative? Both this one is more basic acid, but they are of different strength. So that's why this statement is not correct, okay? So which one carries less negative data? This one, more negative or less negative? Strong acid, strong alkali. Yes, strong acid, strong alkali is more negative. Yes, that's right. Thank you. 33. 袁天佑. And I invite Yong Jing Lam to try 34. Where 50%, 50 cm cube or 1 molar NaOH and 50 cm cube 1 molar ammonia are completely reacted by 1 molar HCl, the same temperature rise will be observed. They have both chemical, they have the same concentration of hydroxide ions. First statement is wrong. Second statement is not the same. Which one has a greater temperature rise? Yeah, same concentration. No, this one, higher concentration. Okay, higher concentration. Can you get a point? And the answer is D, 34. 2 more questions to go. Leo. 34. The answer is C. First statement, how wrong it is? Comparing with the reaction between 50 cm cube 1 molar HCl and 50 per cm cube 1 molar NaOH. The reaction between 100 cm cube 1 molar HCl and greater temperature rise. 50, 1 molar, 100 together 1 molar. Yes. How wrong is the first statement? It's not greater. So now, if you want to calculate amount of heat release for that 2 cases, right? This one, the heat release will be doubled. Okay, this if it's H, this one is 2H. But we have got the mass, it is M, which is 2M. So if you want to talk about M is equal to H, MC delta T, we've got that delta T here. How about that delta T? Okay, this one, the delta E is still the same. It seems like we have got 100 cm cube, 100 cm cube of alkali and acid. I split it into 2 parts, 50 plus 50. Okay, and I mix 50-50 only, the same as the first case, right? Of course, 50-50. I mix it together. It's the same as the first case. We've got the 2 solution with 100 reaction mixture mixed together. Do you have a further temperature rise? No. Well, the temperature rise is still the same as the first case. Can you get it? So the answer is cross-antic is C. Can you get what I mean? You get it? You just write down okay. Many of you just said okay. I cannot comprehend what it means by okay. Get it? Okay, it can refer to so many cases, right? If you use different notation, different feeling to express the word okay, which means different things. 35. 趙家明嚟嘅。趙家明。6 more questions to go. Comparing the reaction between 50 cm cube 1 molar HCl and 50 cm cube 1 molar NaOH. the reaction between 50 cm cube 1 molar exit and 50 molar 50 cm cube 1 molar anyway give a greater temperature rise. Who gave a tick? Who gave a tick? 趙家明、李振傑 greater temperature rise. The combination of these greater temperature rise. Can you get a point? It's not correct, it's wrong. Quite the opposite. It's a smaller temperature rise for the weak acid, strong alkaline combination when you compare with strong acid, strong alkaline. Okay? It's wrong. The second statement. pH value is higher than that. It is 1 molar, okay? It's correct. It's C. Why? Lower concentration of hydrogen ion, which means pH value it is higher. 趙家明, you get a point? Why? Why you compare these two? The hydrogen ion concentration, they are not the same. This one is just a weak acid with slight ionization of the acid in water. So, right? So you know that the concentration of hydrogen ion for ethanoic acid is lower, so the pH for ethanoic acid is higher. Why do you know? Can you get the point? Why? It's because of the calculation of pH. It is like a negative log scale. 趙家明, you get a point? I just mentioned it okay again. I said before what is mean by okay. The last 5 questions before you end up the lecture today. It is 35. Last 5 questions. Can you see that? Can you see this one? From question 36. Can you see this one? The last 5 questions. 温子慧. Good morning. Why you come back so late? Bangkok time, okay? You just arrived in this classroom in Bangkok time. So Wan Ziwai, could you please help answer question 36? The first statement is correct. My second statement is correct. Enthalpy change of reaction depends on the initial state, final state, but it's independent. Wow. What is that? What is the description? The description of Hex's law. The definition. So this is what I would like you guys to memorize this part. How about this? How about the first statement? Must be determined by indirect method. Must be. No need. What you need to do is to do some data treatment. you can still directly measure, right? So what is the data treatment? The terms, what you say, what you will tell. Draw the two lines, match it as a imaginary maximum temperature. So yes, we call that extrapolation, right? The technique, we call it extrapolation that you need to know. So cross and take C. How about 37? Column. The enthalpy change of formation of magnesium hydroxide can be determined directly from experiments. Formation, okay? It's D, cannot. Okay, why? Why can't? Magnesium hydroxide can be formed directly from its constituent element, okay? So if you put the opposite meaning, here comes cause-and effect, right? Can you get a point? Because for the formation of magnesium hydroxide, it makes what? From magnesium, first of all, it's 1 mole of magnesium hydroxide, right? It's solid. So I need what? I need hydrogen gas, 1 mole, oxygen gas 1 mole, and 1 mole of magnesium to form this compound. So what will happen if I get mix of 3? You cannot directly produce as hydroxide. Okay? Can you get my point? So at room temperature, very often, the magnesium will slowly oxidized. Is that okay? Maybe some of you may argue, I have got hydrogen oxygen, they will form water, but sorry, for the standard conditions, or without any ignition, without any excitation of a chemical species, sorry, there will be no water to be formed. No need to mention some other different combinations, right? So for the production of Mg magnesium hydroxide from its constituent element cannot go by its own. Okay, so the answer is D. You get the point? 文希 38. The standard enthalpy change of the composition of calcium carbonate can be measured directly. Calcium carbonate decomposes to give the spot. Second statement, of course, no need to argue, right? It's correct. How about the first statement? Standard enthalpy change of decomposition of can be measured directly. How? So which means that we have got that calcium carbonate, it is solid. Okay, it's solid. Can you measure the change in temperature easily? The answer is no. That is the first reason. Okay, it's difficult to measure the temperature change of a solid. Second, we've got the second reason. Can you see the second statement? When heated. So which means that the reaction for this decomposition of calcium carbonate cannot go by its own. Okay, you need some you need to apply heating to it in order to make the decomposition of calcium carbonate happen by itself, right? So it's cross and take. It's C. Do you understand? Great. 39. 温子偉 cross take is C. How wrong is the first statement? It's again cannot. Yes, carbon monoxide, incomplete combustion. So what is the relationship between the two statements? Go back to the questions. Okay, go back to the questions. We are going to measure the delta H formation of carbon monoxide. Okay, theoretically, if you carefully control the carbon and oxygen, right? Can you get 1 mole of CO for sure? The answer is no. So what would be expected, or what would be the possible products to be formed? Yes, we have got CO2 as well. So you cannot use the direct experiments to measure that delta H. Can you get a point? Cross and take. It's C. How about 40? The last questions. Both are wrong. How wrong are they? Is D? How wrong are they? Methanol can be obtained by the. It's not underlying school lab. Even though outside school lab, you still cannot. Carbon, hydrogen, oxygen cannot just place it here and react together to form methanol. The key is not school lab. In the world, okay, we cannot use this to produce methanol. So how about the first statement? The standard enthalpy change of formation of methanol is a sum of this. It's not the sum. It's not the sum. So can you do you still remember the formula? Standard enthalpy change of formation of this one. Yes, delta H. Do you still remember that? You need to go back to the enthalpy cycle, right? Standard enthalpy change of formation of methanol. Methanol, which is come from what? Graphite. Oh, the last question is very meaningful, right? This time, just recall something that you ought to know. Formation of methanol. This is what I would like to talk to you about, the formation of methanol. So what do you want to refer? If you write down CO2H2O, which means what's wrong with the statement above? First of all, formation is not correct. Second, the sum is also not correct. If you step back to your own method. So if you write down this, which means I need to add O2 as well, right? How many O2? How many extra O2 here? In order to make the combustion here. Correct. 1 carbon, and then how many hydrogen? 4 hydrogen is 2, right? And then 2O, 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 which means O2, how many? How many more? It's 4O. How about the O? Yes, it's 3/2. 3/2. And then, how would you relate that 3 times? So that 2 arrow, what is that? Do you know what that 2 arrow, what is that? Do you still remember that? Okay. So delta H of formation of methanol is equal to what? Delta H of what? Combustion of graphite. Okay, plus what? 2 times delta H of combustion of hydrogen. Okay, and then how about delta H of combustion of methanol? We've got negative value, okay? Delta H of combustion of methanol. Do you still remember that enthalpy cycle for the rest of you? Do you still remember this one? If you still remember, thumbs up. Don't remember. Okay. Just put the thumb down. Just 4 of you. Just 4 of you. 5 of you. Forgot. So as I said before, you guys should be prepared for the coming final exam. It's full paper 1. That one you need to know. You need to know how to draw a correct enthalpy cycle. Okay. So do you feel better after today's lecture? Energetics. What will you feel? Easy, difficult, or what? I do hope it gives a quick start for you to get prepared for the coming class resumption. Okay, how about the others? All gone already? I just want to double check who is absent today. We've got 20 guys. It's just 19. 黃家豪 18. 黎允正 is 17. 李彤 again. Who else? 蔡俊明 Who else? 盧兆華 is here, right? 吳正豪 Ricky 李健朗 Who else? Just 4 of you absent? No? I'll take a look. I'd like to check the name list. Name list. 20. Here we go. Who else? 梁少文 李卓俊 right, absent. Who else? 蔡明 absent. 林允正、李健朗、盧少華、文希、余之浩、袁之浩。Okay, those 5 lucky guys, huh? I will ask them guys to give me the follow up. Okay. So much for today. Goodbye. See you tonight. We'll start over another topic.